So students, our today's topic is determination of chloride content of deodorants and antiperspirants by indirect method. Now, as we discussed previously, the determination of content of aluminum and zinc, for that we utilized a direct method, whereas for the determination of chloride we utilize a indirect method. So for determining the chloride content of deodorants and antiperspirants by atomic absorption spectroscopy using indirect method, we employ the use of excess of silver nitrate solution, and requirements for this would be given sample of deodorant or antiperspirant, concentrated nitric acid, silver nitrate, sodium chloride and chlorine free distilled water. So first of all, we need to prepare a standard solution of silver nitrate, say having concentration of 5000 ppm of silver. So for preparing a standard solution of silver nitrate having concentration 5000 ppm of silver, we will take silver nitrate. So as the molecular weight of silver nitrate is 170 grams and atomic weight of silver is 108 grams, so I can say that 108 grams of silver is equivalent to 170 grams of silver nitrate. And from this I can calculate that 1 gram of silver is equivalent to how many grams of silver nitrate? 170 divided by 108. So this comes out to be equal to 1.57 grams of silver nitrate. Now what is the meaning of this? It means that if I dissolve 1.574 grams of silver nitrate, then it will contain 1 gram of silver. Now 1 gram is equal to 1000 milligrams. So if I dissolve 1 gram of silver, which is equivalent to 1000 milligram of silver in 1 liter, then our solution will be having 1000 ppm concentration of silver. So for preparing 5000 ppm solution of silver using silver nitrate, we need to multiply this weight, that is 1.574 by 5. Why? Because we calculated this amount for 1000 ppm and for 5000 ppm it will be 5 times more. So if we dissolve 1.7574 grams of silver nitrate, which will be having 1 gram or 1000 milligram of silver in 1 liter, then its concentration would be equal to 1000 ppm of silver, as I told you. So in order to prepare solution having concentration of silver 5000 ppm, we will multiply it by 5. So 1.574 into 5 will be equal to 7.850 grams of silver nitrate. So if I dissolve 7.850 grams of silver nitrate in 1 liter of chloride free distilled water. Why we are taking chloride free distilled water? Because we are determining the amount of chloride content of deodorant or antiperspirant. If we will use normal water, that may contain chloride already in that, so we will use chloride free water so that there is no external chlorine in the deodorant, I mean to say from the water. So the solution prepared by dissolving 7.850 grams of silver nitrate in 1 liter of water will be having concentration of silver equal to 5000 ppm. So this is our stock solution of silver having concentration 5000 ppm. Next we will prepare another solution, or we need to prepare another solution of, or I would say standard solution, and that will be of chloride, and we can prepare that by using sodium chloride. So we know that the atomic weight of chlorine is 35.5 and that of sodium is 23. So the molecular weight of sodium chloride is 58.5. So I can say that 58.5 grams of silver nitrate contains 35.5 grams of chloride or chlorine. So I can write that 35.5 grams of chlorine is equal to, or chloride say, is equal to 58.5 grams of NaCl. And from this, 1 gram of chlorine or chloride would be equal to 58.5 divided by 35.5. So this comes out to be equal to 1.648 grams of NaCl. Now, what is the meaning of this? The meaning of this is that if I dissolve 1.648 grams of sodium chloride, it will be having 1 gram of chloride. So if I dissolve 1 gram of or this much weight of sodium chloride, then it will be having 1000 milligrams of chloride. So we will get 1000 ppm concentration of chloride in NaCl solution. So we will dissolve 1.648 grams of NaCl in 1 liter of water, and we need to take chloride free distilled water. This is the standard stock solution of chloride having concentration of chloride equal to 1000 ppm. And then after preparing the 1000 ppm stock solution of chloride, we need to prepare standard chloride solution of concentrations 25 ppm, 50 ppm, 75 ppm, 100 ppm by dilution of 1000 ppm chloride standard solution using chlorine free distilled water. Now you can easily prepare them by diluting 1000 ppm concentration of chloride solution. You just need to dilute them, and I had already told you that how to dilute or make dilute solutions by using a concentrated one. Next is preparation of sample solution of deodorant or antiperspirant. So for preparing the sample solution of deodorant or antiperspirant, for determining the amount of chloride, we need to take known weight or quantity of the deodorant or antiperspirant sample, say 10 ml, and we will add 2 ml of concentrated nitric acid to it, followed by 10 ml of 5000 ppm silver nitrate solution to it. Mix the contents thoroughly and dilute to 100 ml by adding chlorine free distilled water in a 100 ml measuring flask. Transfer 50 ml of the above solution to a centrifuge tube and centrifuge for about 5 to 10 minutes, and then collect the supernatant which will be having free or unreacted silver in it. Now what is the purpose of using silver nitrate here? As our deodorant or antiperspirant contains chloride ion, so by adding standard solution of silver nitrate, we are going to precipitate chloride ion in the form of silver chloride. Now why we are centrifuging the contents after adding silver nitrate? Because silver chloride will be formed in the form of white precipitates. So by centrifuging the resulting solution, we will separate them, because upon centrifugation, precipitates of silver chloride will settle down at the bottom of the centrifuge tube, and supernatant will not contain any of the silver chloride. That will contain unreacted or free silver in it. And after that, we will repeat this same process, that is addition of silver nitrate and centrifugation using standard chloride solutions having different concentration like 25 ppm, 50 ppm, 75 ppm, 100 ppm, and we will collect their supernatants also. So after this step, what we will be having? We will be having a sample of deodorant, supernatant sample, I would say more appropriately. We will be having supernatant of deodorant sample and supernatant of chloride ion solution which has been precipitated by adding silver nitrate of concentration 25 ppm, 50 ppm, 75 ppm and 100 ppm. Here I mean to say that those solutions of chloride which we prepared, we will precipitate them all by using silver nitrate solution and will centrifuge them and will separate silver chloride precipitates of all. Then we will get supernatant of all these different solutions, all these solutions of different concentrations. So we will be having different concentrations or solutions having different concentrations. Then we will record their absorbances. Now what we will need to do for taking the absorbance, we will fix the wavelength of instrument at 328.1 nanometer and will measure the absorbances of different supernatant solutions of concentrations 25 ppm, 50 ppm, 75 ppm and 100 ppm using nitrous oxide and acetylene flame. Then we will measure the absorbance of the supernatant prepared from solution of deodorant or antiperspirant. Then after that we will plot a graph between absorbance along y-axis and concentration of chloride ions in ppm along x-axis. Then we will get this sort of graph as we got earlier in case of aluminum and zinc. We will get different points and when we will connect them we will get a straight line. So in this graph absorbance is along y-axis in green rectangle and concentration is along x-axis in red rectangle. So please note here that all these absorbance readings of different solutions or solutions of different concentrations, say 25, 50, 75, 100 ppm are recorded at 328 nanometer. That's why I have written at the top of the picture absorbance is at 328 nanometer. Then by marking the absorbance of given solution of deodorant or centrifuged supernatant of deodorant or antiperspirant along the y-axis we will get a point which I have marked in oval orange oval, and when we will plot that or extrapolate that onto the x-axis, it will cut at some point on the x-axis. So that point where this extrapolation or extrapolated line will cut will give you the concentration of chloride ion in the given sample of the deodorant or antiperspirant. So this is how you can determine the concentration of chloride ion indirectly. Why indirectly? Because in earlier cases when we were determining the concentration of aluminum and zinc, we employed the use of standard solution of the same metal. That is, in case of aluminum we employed standard solution of aluminum and in case of zinc we employed standard solution of zinc. Whereas in case of chloride ion we are not measuring it in terms of chloride ion concentration, but we employed the use of silver nitrate. So we prepared the standard solutions of silver, and by measuring the absorbances of different solutions of silver, we measured the amount of chloride present. So this is all about the estimation of chloride content of deodorants and antiperspirants. Thank you.